Hello, everyone. Hope everyone has had good lunch and that you're not too sleepy, because after lunch I tend to get my power nap in, so let's see. For those of you that don't know who Binary Edge is, actually, let me get a quick measure. If you've heard of Binary Edge, can you put your hand up real quick? That's not too bad. So we, every time, if you've seen a talk done by us, it will probably have been on internet scanning, because that's what we do. We scan the internet around 250 times per month on different ports. We consume that data, we sell that data, we do stuff with that data. But this year we actually decided that we wanted to talk about something new that we've been doing. We understood that by just scanning the internet or talking to the internet, we were actually having a bit of a gap, which was, who else is doing it? What are they doing? What can we learn from it? And we decided to give this talk about a new system we set up that involves actually having honeypots. And I wanted to talk a little bit about some of the things we've learned with the data, and if it's worth or not for you guys to have a honeypot these days. If I can ask one more question, which is important for this talk. How many of you work in a monitoring position, like a SOC, a NOC? Can you just put your hands up? Okay, cool. So this is our agenda for today. The things that we do at scale. That means, having them spread all over the internet, not just like one honeypot or two honeypots. It means they need to be replicable, fast, and do a bunch of more interesting things. We're going to talk about some of the data and some of the things that we found in terms of patterns and anomalies, and also what are the benefits to having honeypots these days. So, when thinking about honeypots, we decided that we wanted to understand what other people were doing. We thought, okay, so what are the honeypots requirements for us? And we ended up, gathering this list. It needs to be portable, run on x86, x64 or ARM, because we might want to put it in a server. We might want to put it in a Raspberry Pi that sits at home as well, because there is a difference between listening on an enterprise IP address and listening on a residential IP address, so we needed to make it compatible wide. We needed to have dynamic configuration deployment, and what this means is we needed to edit one file, commit that file, and essentially change the configuration globally on all of the honeypots. That means, for example, if on port 80 we want to start giving a specific response on some specific honeypots, I do not want to connect to all the honeypots. I need to edit one file, edit that one file, and it deploys to all the honeypots in one go. They need to be easily deployment, because we deploy, at least for scanning, around 200 to 250 scanning agents every month, and we rotate them all. We wanted to be able to do the same thing for honeypots. A new data center pops up, we need to be able to deploy in there within seconds. Real time. If you've used the Binary Edge platform or you know about us, you know that all of our platform works in real time. Everything is an event. That's why we also needed event-based, but everything works in real time. If someone connects to one of our honeypots, we want to see that event within milliseconds on our central platform as well. We needed a tagging system, because one of the important things is not just about receiving traffic, right? You need to understand what that traffic means, and we wanted to be able to give tags specific to the events, and we're going to go through what all of these things means. And we also needed anomaly detection, and again, we'll go through what that means in a little bit. So, what we landed on was having a custom written solution in Python 3. And for the tagging and the configurations, we have these files. And if you guys look at them, they're actually fairly simple configuration files. So for example, if on port, if we receive a string called EHLO, which is typically for SMTP and mail stuff, we want to be able to reply with 220, census internet org, SMTP, postfix, or exim. And why is this useful? Because if a vulnerability pops out for a new piece of software or anything, we can emulate that software super fast, because we just need to deploy a response, and all of our honeypots start immediately answering correctly to the payloads that are being sent. Again, we deploy our honeypots worldwide. Every time a new data center pops up, AWS, GCP, every time we have a friend that says, hey, I have an IPv4 and I don't mind hosting one of your Raspberry Pis with, on my home, we have scripts and automated the entire thing that we can deploy all of our honeypots worldwide. This is our current data center deployments, and they're fairly well widespread, and we're adding more and more every month. As I mentioned, every time a new data center pops up, we just run a script that deploys on those regions. For example, these were the last ones. Microsoft Azure opened in Switzerland, AWS in Spain, and Azure then opened again in Norway. And for us was literally like just typing one command in the command line, and we get a honeypot spun up and feeding our main platform instantly. So I'll pass over to Florentino, who's going to talk a little bit about our architecture and some of the decisions we made there.
Now, for the architecture, we try to keep things simple, but also fairly dynamic and scalable. So we have all these machines that we call sensors that are really lightweight machines that the only thing they do is receive those events, receive those attempts of scanning. Those machines then send that data to a sink that sends that data to our data processing infrastructure. Our Kafka is our main repository of events, and then we use Storm Cluster to process the events. And the processing we do here is that tagging that Tiago mentioned, and we also enrich the data with ASN, RDNS, and some other stuff that we find necessary. Then we import this data to our database. And if you were to go to our website right now, our free binary edge portal, you could see the sensor data that the sinkhole data that we have been receiving. And, well, that's pretty much it.
So when you look at an event, this is pretty much what it looks like. And I'm going to go from top to bottom. Client ID is just an internal ID that we use. It's from a sinkhole. The timestamp, every single event that we create or that we receive has a timestamp associated with it. The IP on origin is the machine that tried to connect to our honeypot. The type of the event, again, it's something that we use internally. ASN, the ASN that the IP belongs to. And then there's the data part. We generate an hash for every single payload. We actually have a copy of the entire payload, and we generate extra metadata regarding some payloads, and we'll go over what this extra metadata allows you to. Then we have the tags associated, so we can see that this guy was doing an SSL scan of some sort, and we have the target, so the honeypot that he targeted on our side. As of today, we have 266 tags, and this is super useful to try and really understand what an IP address is doing, because we need to understand that not everyone on the internet is malicious, not everyone on the internet is benign. Maybe some of you freak out a little bit when you see binary edge hitting your IP addresses. Other people love it because they get to log into our platform and understand their exposure without having to pay a lot of money. So we try to classify and add as many tags as possible to our events. This is done by having configurations deployed on these different files. Florentino, do you want to give just a quick explanation on that?
Well, like Tiago said, we try to have a simple way of configuring things. So these files, these JSON files, they follow a simple structure like Tiago showed before, and we can do tags on pretty much everything we want. We tag based on ASN, based on HTTP requests, based on fingerprints such as GA3 or AJSSH, RDNS. And then we have general tags that it's basically tagging on the payload itself. For instance, this is one of the tags that we have for an SMB scanner. We look at the payload in itself and we look for certain markers that we know if the payload contains this, then probably it will be an SMB scanner. And like this one, we have lots of other ones. And basically, this is our own DSL, our domain-specific language to tag all these events, and it's as flexible as we want. If we want to add new functions to this to make it more complex, we can, because it's custom made.
One of the important things is Binary Edge on its side has two versions of the platform. We have the enterprise version, which is for enterprise clients. We sign contracts, we do the entire shebang. And we have the free version, which as a community, you can come in, you can use it for free. If you want some extra credits, put your credit card, but you can also contribute and get credits for that. And we actually have a person that contributed 92 new tags in the space of about a month and a half, and we actually ended up hiring him. He's sitting front row, he's joining Binary Edge in January, Philippe. And we have other people in the community that do this as well, because they are trying to use the sensor data for themselves, and they end up enriching our own data with their knowledge. So we had to make something that was super, super simple to write instead of having them write actual proper code. But, you might be asking why. And if you've worked in a SOC, you might have maybe an idea of why it's useful to have this stuff. So internet scanning has come a long way. I'm sure, if I ask if you know Shodan, 90% in the audience would raise their hands, right? But these days it's not just Shodan anymore. There's us, there's Sensis, BitSight does their own scanning. Robert Graham, as an individual who created MassScan, does their own scanning as well. There's ZoomEye, Quadmetrics, Rapid7, and of course, this generates a lot of noise. If you're listening to your perimeter, if you're monitoring a firewall, it really makes a lot of noise. And to prove my point, I'm actually going to connect to our real-time. Hold on. Am I going to connect? Maybe. Oh, hold on. Yeah, of course. Just a second. New laptop and things fail. So this is actually our sinkhole stream in real time. This is the stuff that's hitting our honeypots. And as you can see, trying to identify all of these things is a pain. And if you're an ISP or if you have a lot of assets exposed to the internet, you're getting just as much traffic as we are. And if you're monitoring an IDS or a firewall, you're going to see lots and lots of this. So it's super useful to have something that enriches, that tells you what those things are. Why? Because it allows you to prioritize. And going back to our presentation, if we can find it, Google Sheets never again. Really? Really disappeared? Jesus. There we go. Let's try this again for the 100th time. There we go. So if you work for a SOC or a NOC, this should be familiar to you, like an IDS throwing a bunch of warnings. But what if we could have an enriched version of that? That means you could reduce your SOC exhaustion. You don't need to focus on 90% of the events. Why? Because these will be typically general scanners that are scanning the entire internet and are not focusing on you. And you should actually enrich your service, be it with Binary Edge or Gray Noise, for example. Maybe you've heard of them. I'm technology agnostic, even though I own one of the companies. But use whatever you want. But essentially, it reduces the exhaustion of the people working at the NOC or at the SOC, because they only need to focus on things that are specific to their assets instead of looking at things that are hitting the entire world. Of course, this also allows us to detect funny things. So we found these numbers to be quite high. There's a Russian ASN, and if you can see there on top as well, that Russian is the top country scanning. And what are they scanning for? RDP scanner. And this gives you a bunch of ideas in a couple of different things, and we'll go over those as well. But we also detected down there version 1.16- version on the HTTP paths. And we actually explored what this was. And we did a bunch of changes that allowed us to go a little bit deeper on this. Of course, we also find fresh malware on the honeypots, and you can also monitor your IP addresses. So if you see one of the IP addresses that you own talking to one of our honeypots in the platform, you have some issues. Unless you run a scraper or you do your own internet-wide scanning, you're probably infected with something, or you've probably been pwned, and it's something you should keep an eye on. I'll just pass over to Florentino, who's going to talk a little bit about some of the problems we ran into when building our own custom honeypots.
Now, for the case of UDP, it's fairly simple. You can just open a socket and listen, because there's no connection, there's no complication there. So basically what we did here is we created a socket and then we used some firewall configurations to redirect everything to the port that we have the socket open. You could also create a raw socket and just listen to everything, but there's too much noise there and you definitely want to filter out some ports. Now, for the case of TCP, it's much more complex because you will have to have something binding to the port if you want to receive stuff. So we needed to create a version of this that built the connection, the full TCP handshake, and another version that used the raw socket to catch all the TCP SYNs. And this is needed because nowadays port scanning is mostly based on SYN scan. It doesn't finish the connection, so you need to catch both things. But then you also need to catch the SSL connections. So you need to complete not only the TCP connection, but also the SSL handshake and catch whatever is beneath all that. So there, it's fairly complex. You have to, and you need several sockets open. And again, we did this also using some firewall rules. So we open one port and redirect everything to that. So one thing that comes to mind many times is why not use just something like TCP dump or Wireshark? And the thing is, in itself, it's not enough, it's useless, because you do need to have something underneath that completes the connection. So that's why we thought of building this all custom made. And the good part is that because of this, we also we can manipulate whatever we want. And when we had the question, can we respond to these requests any way we want? It was easy because it was our code. We just needed to insert some packets in the middle and it's there. Another problem that it's probably the biggest problem we have so far is the volume of stuff. Like when those Russian guys start scanning for RDP like once a month, it's really the worst part for our infrastructure, because the density of data that comes per second is really high. So we need to have a really big cluster to handle all of that. And well, it's fun. Let's just say that.
So now that we have infrastructure in place, I mentioned, for example, malware. And with malware, we can do lots of different things. We have importers that can enrich data with things like VirusTotal, AnyRun, JoeCloud, or even from Binary Edge itself. So, for example, if we want to see if the people scanning for RDP had the RDP port open itself, we can enrich our honeypot data with our scanning data as well. We started finding a couple of interesting things. So, for example, we get things like this that get tagged as malign. You see that there's a wget in there with the URL, and then you check, and it's just malware in there, of course. And as I mentioned before, we have metadata that we generate. And we generate two types of metadata right now, GA3 and AJSSH, and you might see them here. And what are these two things and why are they useful? So GA3 is essentially a signature on the SSL connection that the clients that are connecting to our honeypots are using. And it generates fingerprints. This is not new. This was invented by the team at Salesforce. And we add it to every single SSL connection that we receive on the honeypot side. You can see here the explanation. It generates the SSL GA3, which is the version, cipher, extension, elliptic curve, and the point format. And then the digest is the MD5 of all of these things concatenated. AJSSH, it essentially uses the unencrypted part of an SSH connection, concatenates all the algorithms, and then generates the MD5, which generates the AJSSH signature. And this allows us to do two types of things. Number one, actor clustering. So IP addresses that belong to the same actor, because it generates a signature for the tool that that actor is using. And it also allows us to find common tooling. So how many people are using the same tool to scan for SSL? How many people are using the same tool to scan for SSH? And if you have an actor that, tries to hide from our honeypots, from our tagging system by changing IP addresses, well, they'll also need to change the signatures on their tooling because we catch them that way. With this, we can generate an image like that. And you can see that there are a bunch of clusters. By combining the ASN information and our tagging system, we can enrich this image this way. So we can see that there's a cluster for binary edge, there's a cluster for bit site, one cluster for Shodan and Sensis because they use similar tooling, and this is specifically for SSL scanning. There's a large cluster of IPs from Iran and China that they're using similar type of tooling as well. And this is kind of interesting knowledge because you can really start to identify like when they're trying to hide. So if an actor all of a sudden decides that they don't want to have the reverse DNS or rotates all of their IP addresses, we can still catch them on the signature of the tooling. Same thing for AJSSH, but what this tells us is that there is a lot less tooling being used to scan for SSH because you see a lot less clusters that you saw with TLS. And then you start seeing weird things. So on our honeypots, we started seeing Accenture ASN or IPs from the Accenture ASNs starting to scan or do TCP scenes on our honeypots. Anyone has a clue why this happened? So essentially they were spoofing the IPs from Accenture. You see this typically when someone is trying to throw the blame at some other provider. And how do we know that this is spoofing? Because spoofing has a very typical signature. You only see TCP sins because they never complete the handshake, and you see very direct, very small spikes because they rotate trying to emulate who they're trying to spoof. We also saw the same thing happen to a bank, SunTrust Bank. They had the same issue. And then you start seeing even weirder stuff. So we started getting a bunch of SSH connections, and if you guys look at the RDNS, navy.gov.us, and we're like, okay, that's really weird, because in this case it wasn't just TCP sins. Like the connection was actually happening and we were getting like full packets. So what was happening there? And what happened there is that this IP address actually belongs to a provider called Frantech, which doesn't verify the reverse DNS on their end, and someone just set up the reverse DNS to pretend to be Navy Gov, and they never did a confirmation on that. Same thing, so HTTP paths, we monitor HTTP paths, and we started seeing a very large spike on V116 version. And what's happening there, we started to see that we were not emulating the correct response because we would only get the initial HTTP request. So we took a look, we noticed that it was a request for the Docker API. And all Florentino did was literally commit this to a repo, and then we started seeing the entire connection, like actually dropping malware. They have a curl up there, and essentially it deploys a container that starts to mine for Monero. The cool thing is, because the way our system is developed, when we detect certain strings, all of these automatically got tagged as malign and malicious. We didn't have to do any changes for that. And this is just some of the stuff that was inside the malware that was deployed. And you can see that it's essentially a Monero miner. You start seeing things happening in the real world reflect on your sensors as well. So the Dutch police took down a fairly large DDoS botnet provider, and we saw a reflection of these on our sensors as well. So if you look at the date here, October the 2nd, immediately on our sensor data, because we knew the IP range, because we were working with some people that were helping on this, we saw an immediate drop of any events coming from them. So that's how you see that, what's happening in the news is actually effective. Who knows what this is? Any ideas? CV 2019-0708. Bluekeep. Published date 05/14/2019. And we started seeing that lovely Russian ASN a couple of days later doing something very, very interesting. We call it an inventory scan. They were not exploiting Bluekeep, but they are checking every single IP in the internet on every single port if they are exposing RDP or not. At some point, they might trigger exploitation, but they're essentially looking at the 65,535 ports of every single IP on the internet if it's exposing RDP or not constantly. And this generates a very, very large volume of data. And you can see that we went from having 0 to huge amounts. And it's still going on, by the way. If you can, ban this on your edge, this ASN, do it. You'll be doing yourself a favor. You also find things that are really cool. So there was a vulnerability that came out for Confluence on the 12th of April. and immediately, 2 days after, we started catching an IP address exploiting that. And this is actually really cool because it's super interesting to measure from a vulnerability when it gets announced to how soon we start to see it getting exploited. And of course, because we get to see the full payload, lots of times we get to see what sort of malware is being deployed, what type of exploitation they're actually doing, all of that. So what are some of the things that we want to work in the future? Fitting the binary edge use case, what we do is, if you give us an organization name, we need to figure out IP addresses and domain that belong to that company. And then we need to figure out what they're exposed or what they're involved in as well. So we have a system in our sensors, in our honeypots, that consumes all of these events and looks for anomalies. We call it Snugglebot, and you can see here that it looks for different things. It looks for spikes in IP addresses. It looks for, as you can see here, spikes in countries, ports that are being targeted, certain payloads, certain HTTP paths, because it can give us an idea of, is there something new being exploited? Yes or no? Who is exploiting it? Are we seeing mass scan for something new that we haven't seen before? Is this a new actor? Yes or no? And we have an entire automated system that gives us this anomaly. But these are still very raw events. What we're working on right now is essentially the anomalies becoming stories. And a story is essentially the beginning of an anomaly, the end of an anomaly, and all the tags that enrich, that tell that story of that event, and the IPs that have participated in that event. Because that's super useful, because if you find one of your IPs talking to our honeypots, you're immediately going to be able to search when they were scanning the honeypots, what they were scanning it for. Essentially, instead of having to go through the raw data, we do the enrichment for you, and you don't have to have all that extra work. And we're also working on something we call the internet scanning ethos. And the reason for this is because we're starting to see a lot more malign and non-benign, and these are two different things, actors showing up. And what we've decided is that from now on, we're setting a bunch of rules to ourselves and to our peers that scan the internet. If you're scanning the internet, you need to have reverse DNS set up on all your scanning IPs. You need to send non-malicious payloads, be responsive via some type of communication method, respect a blacklist and data removal, and actually do throttling if people ask you to, because we do all this, and we don't want to break the internet. We're not here to hack organizations. We're not here to do anything of that. And we expect the same type of behavior from our peers in the industry. And what happens is, if our sensors catch an actor that is failing at one of these, we will immediately tag you as malign. And you might ask, why do I give a fuck? Reason for that is very simple. We're going to start offering blacklists for free to every organization that wants it. You want to load a list of malign IP addresses at your edge? We're going to give you a list for that for free. Load it up in your firewall, load it up in your IDS, start blocking those guys because they're not behaving, so you need to put a stop to that. And we're hoping more and more organizations start consuming these blacklists and start blocking people that don't know how to behave and that are not helping you secure your organizations, because that's the objective of our internet scanning. If you want to try and play with our data, app.binaryedge.io, promo code BSides-Lisbon2019 will give you 6 months for free. Not actually free, you'll have to pay €1, but that's because our card provider doesn't allow us to do for free because they need their own money. But it will be €1 nominal fee, and you can play with all of the data. This will give you full access. Scanning data, data leaks, domains, sensors, all of it. The only thing that we ask back, feedback. If there's something you think we can improve, if there's a tag that you can provide us, we appreciate it because it helps everyone else. Any questions?
Hello?
Thank you, Tiago. We have one question.
Hello, good afternoon. I have a question regarding the blacklists. If someone gets on the blacklist, how can they remove themselves from it?
Sure. So one of the bigger problems of blacklists these days is that they have no time measurement. You jump into one, you're going to sit there for a month, and if it's a nice blacklist provider. With us, you jump on our Slack channel or talk to us on Twitter, and we will remove you from the blacklist, assuming that you're following the ethos, of course.
Okay, thank you.
Anyone else?
Yes. Oh, yes.
Yeah.
Sorry. So, what platform did you do the honeypot in?
We wrote something fully custom done in Python 3.
Okay. I think I've seen it.
No, it really is something custom. Yes. Any other questions?
Hi, good evening. Any experience regarding the blacklisting and blocking at the ISP level?
So we find that it's a marketing thing, if I'm honest. So we used to be super in the dark. No one knew us like 4 years ago, and we would get blacklisted a lot. It was hard. But now that our name is more out there, we appear on TechCrunch because we helped with the PDL leak, for example, last week, like reviewing it and helping the FBI with that. So the more we find that the more our name gets out there, the less we're getting people asking us to block them, and they're actually starting to work with us. So it's unfortunately very much an image and marketing thing still. You talk to the ISPs, you show them what you have, they start using your platform, and they don't ask you to block them.
Anyone? This counts for two.
Just another question. Since the data gets so large so fast, are you keeping the data for how long?
So we archive every single thing that we scan or listen to. We keep everything available via API for 6 months, everything on the portal for 1 month via UI.
Okay, thank you.
Anyone else? Oh, there's one down there.
I'll get there.
Do you want to shout?
It's a sprint between here and there.
Thank you. So then which kind of database are you using for storing the data? Because if you are storing it for 6 months, then a lot of data.
So raw storage goes into S3, like after it gets out of the 6-month range. The 6-month storage, I believe, is on a Cassandra cluster, and our normal storage would be sitting on an Elasticsearch.
Okay, thank you.
Thanks. And the reason for that is because it's the stack we were familiar with on our scanning side. So we just tried to keep with tools that we're familiar with. And we had the entire system working in less than a month, from like development to having something functional, a month and a half maybe, something like that.
Anyone?
Well, if you have any questions, you can always come up and chat with us. I'm going to be here for a little bit. And thank you very much besides.
Thank you.